we don't know for a fact that 58% of freshmen own cell phones. We just know that coincidentally, based on the sample of 52 kids that we chose, that that's what it was. Okay? So we're not comparing apples to apples here. This is a for sure fact, population proportion. This is just a sample. Could have been very unlucky. Or it could have been lucky. Maybe the actual number of freshmen that own cell phones is only 50%. Who knows? But the idea that we're going to jump into now is trying to figure out how plausible is it that even though we picked a sample proportion of freshmen that was that low, how likely is it that their actual population proportion could be as high as the juniors? Okay, that's what we're going to be on this quest to figure out. And what I'm going to show you is a simulator online that you're going to have to use to do your homework. Of course, you're not going to be able to use this simulator on a test, but you will see diagrams that indicate, you'll see diagrams on your regions I'm talking, that will indicate that one of these simulations has happened, and you will still have to pull the information. So I am going to, and you're going to have to access it on my website as well, and I think I warned you yesterday that your cell phone's probably not the best place to do this. We would like to determine how likely it is that this sample proportion of 0.58 could have come from a population proportion of 0.71. So run the program psimul, and I'll show you where this is on my website. So I feel that people at home aren't going to see this, but let's see. Okay. So right down at the bottom, prior to all this Regents Review stuff, I have the 3 simulators that we're going to be exploring. We're doing sample proportions right now. So if we click on that, it's going to bring us to this website where we are going to hypothetically say that our population proportion, let's pretend that our population proportion for our freshmen was the same as what it was for the juniors at 0.71. So if for our freshmen the population proportion was 0.71, and if we then took a sample size of 52 kids, is that what we did? Sample size of 52. And we are going to run this, and we're simulating, which means we're mocking this potential sample that we took of 52 kids. We're going to do it 100 times over. We're going to take 52 kids. We're going to record what proportion of them own a cell phone. We're going to throw them back, and we're going to retake 52 kids. We're going to record what proportion of them own a cell phone. We're going to retake 52 more kids, and we're going to do this 100 times over. Number of simulations, 100. Do you follow? Okay? And the decimal accuracy, I mean, we actually already did this, hypothetically, the one time in Part B, and we got 0.58. But we're going to have the computer simulate this experiment 100 more times. And when you run your simulation, you're going to get, you have to hit OK when you do that. You're going to get 100 different sample proportions. Okay? And they're going to be in order from smallest to biggest. So if our freshman class actually was up to par with the junior class with a population proportion of 0.71, the lowest number I ever got just by getting super unlucky was a population or a sample proportion of 0.54. You follow that? The highest sample proportion I ever got was 87. So on the low end, 54% of my sample of freshmen owned cell phones when I got unlucky. And when I got super lucky, it was up to 87%, right? This was done under the understanding, or the trying to figure out how plausible it was that the freshman could have actually been 0.71. So on that part A,
How many of these 100 had a proportion less than or equal to 0.58? We just have to count them. How many? How many were less than or equal to 0.58? 2. So put that for part A. 2. 2 out of 100. And you can even write 2 out of 100. Which means 2%, right? You want to add that too. 2%. So if I go back so you can kind of see what I'm referring to now. Could this have happened? Could this 58 sample proportion have come from a freshman class that also owned cell phones at a rate of 71%? It could have happened. But the chances of us getting that low of a sample proportion was 2%. That's pretty low, right? So you kind of make some inferences and some educated, decisions about this. That's a very low chance. Either you're the most unlucky person in the world and you just picked a really bad sample, or the reality might be that freshmen actually own cell phones less likely than juniors. Does that make sense? Lucas Coletta, get your head up. Do not lose me here, okay? Unfortunately, there's not a lot of work I can show. It's all via explanation, and you have to hang on to every word. So, based on your answer to A, how likely is it that a sample of 52 from a population with a cell phone ownership of 71% would result in a sample proportion of only 0.58 or less? How likely? 2% likely. So what's 98% likely is that freshmen actually don't own as many cell phones as juniors do. Okay? The next part says, is it possible? And in statistics, even with simulations, it's always possible. We're always, though, going to be gauging how possible. So is it possible that this sample that we took and got 0.58 for actually came from a 71% population proportion? Of course it's possible. It happened. It actually did happen 2 out of the 100 times. So yes, it is possible, but highly unlikely. A 2% chance would justify highly unlikely. And there's different thresholds where, again, the way you describe things can make or break your answer. Some people might say yes, some people might say no, not particularly in this question, but it's the way you sell it. Okay, because some people, even 10% would be highly unlikely. The threshold is different based on kind of your sensitivity to what you think is highly unlikely versus somewhat unlikely. And so part D is, what conclusion can you make about freshman cell phone ownership compared to ownership by juniors? And give an explanation. So the conclusion I would make, just because this is possible, but we would have been super unlucky, my conclusion would have been that freshmen probably, and you're going to hear a lot of these words, probably, unlikely, but nothing in statistics seems to ever be definite, I will say that. So freshmen probably have an actual population proportion of cell phone ownership that is less than the 0.71 for juniors. Probably. And that's a strong probably in my opinion. Any questions on that? I would say anything, and this is this is not a formality, this is a very loose interpretation. Where I stand is anything less than like 10% is pretty unlikely. Okay? If you're above 10%, then I would say, yes, still unlucky, but not so astronomically unlucky that you would really rule it out. So that's just for me. My cutoff tends to be somewhere around 10%. All right, flip to the back. New scenario here. Let's say we have a population with a 0.25 proportion of being 65 years or older. So we're pretending that in some city, let's say Buffalo, 25% of people are 65 years or older. We know that for a fact. That's a population. They're telling you that we have a population proportion of 25% essentially being 65 years or older. So we're gonna kind of observe what happens when you take different sized samples. Like if I only sample 10 people from Buffalo versus sampling 20 people from Buffalo versus sampling 50 versus sampling 100. Does anyone have any idea what sample size does? What do you think, Lucas? The bigger the sample, typically the more accurate. That's correct. So if I run this simulation and I put in, starting from the top, the population proportion of people over 65 is 0.25. The first one says try a sample size of 10. Does it say how many simulations we wanted to run? We'll do 100 simulations. That's pretty typical. Okay. And then run simulation. And you'll have to hit OK for those numbers to change, okay? So when I only sample 10 people from Buffalo, sometimes none of them are over 65. And on the high end, sometimes half of them are over 65, right? If I only sample 10 people, and I've done this 100 times over, so there's 100 numbers on that list, sometimes, actually several times, none of them were over 65, and then the highest was 0.50. So the low was 0 to the high was 0.50, which is coincidentally symmetrically surrounding the 25%, isn't it? Right? But that's a very big range. So the range there is 0.50. I'm going to do the same thing with 20. So I'm going to double my sample size. My population proportion is the same. But now I'm taking 20 people. So now the likelihood of getting 0 of them to be over 65 is probably going to be a little bit less because I'm taking more people. Run your simulation. Again, not that it can't happen, but it didn't in this. By the way, if you guys were all on a computer right now and you were doing the same thing I was, this is truly a random simulator. Your numbers would not be exact as mine. So on your homework, when you're running these simulations and you're recording these numbers, they should be in the ballpark, but some of you might have just hit run simulation with those same numbers and you might have a low end of 0. Right? Because it could happen. You could grab 20 people from Buffalo and nobody could be over 65. So these are all truly random. If I did it again and reran a simulation, my numbers would come up differently. But for this one, my low end is 0.05, my high end is 0.6. So in that next one, 0.05 is my low to, so even that is interesting. That's kind of bizarre that actually went up to 0.6. But the range did decline. So that 0.6 to 0.15 is 0.45. You already have your homework, right? So you're good. If I up my sample to 50, you'll see as we get significantly bigger that it really should. So now the low end is 0.12, so the high end is 0.15. .38. 0.12 to .38. And the difference between those is 38, 28, 20.26. So do you see how the low to high is pinching in and surrounding 0.25 a little more tightly? 0.25 being our population proportion. If I do this one more time and up my 50 to 100, now I'm taking 100 people from Buffalo and seeing what my low to high is here. 0.10 to 0.32. Point 10 to 0.32. So even that's weird. Again, typically these pinch in, and if we did this a bunch of times, it would pinch in to surrounding, but 0.12 actually went backwards to 0.10. But your range is still getting tighter because 0.10 to 0.32 is 0.22. Not that this is on there, but actually let me take a sample size of 1,000 and run that. If I take 1,000 people, the chances of none of them being over the age of 65 is slim to none. 0.22 on your low end to 0.29 on your high end. That really, 0.22, let's add that column. If I take a sample size of 1,000, my low end was 0.22 to my high end was 0.29. That's a range of just 0.07. Clearly pinching in. The bigger, the moral of this story is, the bigger the sample size, the more accurate to the population. Okay, that's a big thing. Sample size is huge. It's a big factor. If you don't sample enough people or you don't take as many samples, you're leaving a lot more up to the luck of the draw that one time only. Because the chances of you getting super unlucky 1,000 times over get less and less. Okie doke. And then skip C for a second. Jump down to D. If researchers surveyed 50 people walking out of a movie and found that 21 of them were 65 years or older, that means 21 out of 50, let's just call it old, are old. We know what their cutoff for old is. Hopefully we're not offending anybody. If your parents are watching my video, you might be offended then. But 21 out of 50 is what percentage? What sample proportion? What's 21 out of 50? 42.42. Do you believe this sample came from the general population with a proportion of 0.25? Well, let me go back and look at that simulator where I did 1,000. How many of these 1,000? It's hard to tell because there's so many, but there's 100 simulations. I'm sorry. If we took 1,000 people, we didn't take 1,000 people. We sampled 50. Let me go back and change. Our sample size here was only 50 people. Okay. How many of my 100 simulations are 0.42? 2 out of the 100. So there's a 2% chance, essentially, that group of 50 people is a good random sample of people from Buffalo. Okay? I'll say this. So in simulation, 2 out of 100 trials were 0.42 or higher. So there is a 2% chance that this sample is 2% chance that this sample is a completely random one. So what might be the bias here? Because obviously that sample proportion of 42% is greater than what we know the population proportion of old people to be, which was only at 25%. So what might be some biases that were caused by sampling these 50 people? Okay, so potential biases. Time of movie. Okay? And that's because if you go at 1 o'clock on a Wednesday, yeah, you probably are going to run into more retired people than you would if it was 9 p.m. on a Saturday. You follow? Okay, what else? Right, what type of movie? The type of movie. And these are all things that you might have to hypothesize about. You'll never know. But certainly there are certain things about the way you grab these 50 people. What would be the best, most random way to grab 50 people from Buffalo? I don't know. Ideally, if you could take everyone's name and put them in a hat and pick out 50 people, that would probably give you something very random. But I'm trying to think of a circumstance. Going to church would not probably be a good idea. And grabbing 50 people at church, would that be a good idea? No. Grocery store, but you're going to miss out on 18 and under there. I'm trying to think of a place where the mall, that would be a decent one. Restaurant, like something, you'd have to try to find a way to not make it biased. But truthfully, there's going to be a little bit of bias. It's really hard to completely eliminate biases unless you truly put all the names in a hat or put all the social security numbers in a hat and truly grab it out. But you'll be asked to hypothesize about that. And again, there's no right answer. If we can wrap our head around why that makes sense to you, we'll give you credit. But your sentence has to A, make sense, and B, has to have some legitimate reason why your sample could be biased. Okie doke? It's that number and up and further beyond. That's a great question. You guys have your homework, so let me address this question quickly. So it just so happened on this one that our sample proportion of 42% was really the far end. But truthfully, if there was something on our simulator that was beyond 42%, we would count that as well. Because the question is really like, what is the chances we got that unlucky or even more unlucky? Do you know what I mean? So if I had gotten like a .34, I would be thinking, out of my 100 simulations, what are the chances that I got as outlandish